Okay, so I'll go to my calculator now, and I've created a new calculator screen. And there's just a couple of things I wanted to point out, so make sure you're paying attention. Um, on your calculator screen, up here is where it describes the kind of angle that you are using in your measurements. So mine by default goes to radians, and by the end of this lesson, you'll know what radians are if you don't already. But you need to use your cursor to go up to the top here, and when you click on where it says rad, it'll change to deg. If you click on it again, it will go back to rad. So just so you know, that's how you switch between the two. If you think you'll get confused with that in an exam, I tell my students usually to use bring in a scientific calculator that's always in degrees, and then you leave your GDC in radians, and that way you just pick up the right calculator depending on what you're working in. Or you can just use your GDC and switch up here, whatever works. So if you remember, it was x equals 200 over tan of 35 degrees. So I'll literally, in my calculator, I'll just go 200 divided by, now the trig functions are found under the button that says trig. It's kind of handy, isn't it? So hit trig, hit tan, and then inside the brackets here, we just need to type in 35. And then it returns, oh man, it returned the exact value. So I'm going to go Control Enter for the approximate value, which is 285.63. Okay, so now I'll switch back to my sketch. And I can write that in, 285.63. And don't forget units, you will lose marks for not including units in there as well. So 285.63 meters. Okay. Any questions about that before I move on to the next one? And I'll have to do this one really briefly because I've run out of time. It's not 15 minutes up. Okay, cool. Am I going too slowly? Okay, who feels like being a cat? Okay, Joe just put his hand up. I don't know. You just want to be in it all the time, Joe. So there's a cat called Joe. And Joe is looking down at his owner. Who wants to be Joe's owner? Tom does? Okay. His owner, Tom. Bonus, though, is that you get to scratch Tom later. So that's good. Yep. And he has to feed you, might I add, too. And clean out your litter tray, which is a bit disgusting, but, you know, that's cats for you. Angles of depression are taken from the person, the cat, the object, and they are taken parallel to the horizon again, as you can see here, but this time they go down to the object. Okay, we have a 12-meter tree. What we do know is that there are 12 meters between the tree and the person, Tom. Excuse me. And the question is, how high is the tree? So I'll have to do this really fast because I'm out of time. How high is a tree? Or to be more precise, how high up the tree is Joe? How high did Joe climb before Joe got stuck? So if there's a 12-meter distance from here to here, that means there is a 12-meter distance from here to here as well, like so. So that's got to be 12 as well. And we've got this distance here, which we don't know. So let's call it X. So if I pull out the triangle, I've got this triangle here. I've got X here, and I've got 12 here. I need to work out two things. Number one, I still don't have an angle in here. Number two, I then need to work out the ratio. There are two angles I could use. I could work out this angle, and I could work out this angle here. Now, generally speaking, the easiest thing to do is to work out this angle here. Now, the reason why is because this line here, which remember is always taken parallel to the horizon, is therefore parallel to this line, which is also parallel to the horizon, or to the ground, sorry, whatever. Okay, so that means we've got this Z here, and from grade 8 and grade 9 geometry, you might remember then when we have two parallel lines with a traversal line, there you go, it's a fancy word, between them, then this angle here will be the same as this angle here. To put it another way, in the context of the problem, if Tom looks up at Joe, the angle of elevation will also be 50 degrees. So the angle of depression is the same as the angle of elevation. So you can always match them up. The other thing I could have done is I could have just created a triangle that was upside down. Why didn't I? Didn't think of it. Either way, it's a pretty basic thing to see that this must be 50 degrees. Yeah. Yep, you can. Yeah, I didn't say that, but yeah, yes, I said there were two angles you could use, this one or this one. That's 50 degrees because of alternate angles. This is 40 degrees because it's complementary angles. Add up to 90 degrees. Yep, you 100% can do that. This, to me, you're less likely to make, imagine this was like 52.6, something like that. It's a lot faster to go, oh, that's 52.6 as well. It's a pretty small amount of thinking. I don't think that's too harsh to say that. So you've got the triangle there. And again, we're going to use tan because we've got an angle and we've got an opposite and we've got an adjacent. Just for room's sake, I'm going to have to get rid of that. And I'll quickly do it. Tan of 50 degrees is equal to x on 12. So in this case, x is simply going to be 12 multiplied by the tan of 50 degrees. I'll then use my calculator again, pip, 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 and I would get 14.3 meters is the distance of x. But let's just imagine, I don't know how close this is to accuracy, Tom. Imagine that Tom is 2 meters tall. We have to add in the 2 meters to the height that we worked out with x in order to get the actual height. So you would then, it's going to be really hard to put this in nicely, but since Tom is 2 meters tall, Joe is 16.3 meters above ground, or something like that. Okay, now this is a classic example of answer the question, don't just work out what x is. So if the question was how high is Joe above the ground, or how high up the tree is Joe, then the answer is not 14.3, the answer is 16.3. One last thing, then I'll let you go. Go for it with some example problems. Any questions? Am I going too slow? No. That's my question. Next one, I can make these notes available to you if I'm going too fast. And of course, the video will be recorded as well. This one here, just to give you the opposite sort of idea and a bit of GDC work, finding the angle. So we've got a random triangle here that's 9 centimeters and 12 centimeters, and we have to work out what theta is in this instance. So it's the same 3 steps: determine the ratio, substitute in, and solve. So I'll just zoom out now, and I'll solve it down below. And again, I've sort of skipped ahead a bit just to make it a bit faster. What I have is if I'm standing here at the angle, I've got the opposite and I've got the hypotenuse. So in my SOHCAHTOA, that's so it's SOHCAHTOA, so it's sine. So I've got sine is opposite over hypotenuse. In this case, I've got theta, that's the bit that's missing. And so theta is opposite over hypotenuse. And if you want to, because it's easy, you can just quickly make that 3/4 by dividing top and bottom by 3. And therefore, theta is the sine inverse of 3/4. I tend to write that down explicitly as a step because I think it's a good way to remember what you're up to. So sine gives out a ratio. The inverse of sine, which is what sine to the -1 means, the inverse of sine gives out an angle. So what we'll do now is we'll quickly go to the your old pal, the GDC, and I'll show you how to do that. It's in the same spot there, but underneath sine, you can see sine inverse. So I'll go sine inverse, and then you can either go 3 divided by 4 for 3/4. You can waste time and go to your fraction button and put that in and go 3/4. Or you can say, well, I know what 3/4 is as a decimal, and go straight to 0.75. Whatever floats your boat, they all will do the same thing. And then press return, and there's the angle, 48.59 degrees. So you would switch back to your book, switch back to your book. What does that mean? You would write down in your book 48.59 degrees. And I don't think there's any requirement to turn that into degrees, minutes, and seconds from memory. I'm pretty sure you can leave it as a decimal like so. Okay, I've gone over the time limit now, so I'll stop the video here.